Math. When you need help, you use Minute Math.
Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about solving rational equations. We're going to solve each equation, and remember to check for extraneous solutions. So, if I was given this problem, k plus 4 over 4 plus k minus 1 over 4 is equal to k plus 4 over 4k. Well, the first thing I'm going to do here is on the left-hand side, I can add these fractions together. I can combine them because they have the same base, which is 4. So let's go do that. Together it becomes one fraction with 4, and we have k plus 4 here plus k minus 1. And that's equal to k plus 4 over 4k. Now, keep going. Let's simplify what we can up here. We have k plus 4 plus k minus 1. So the k's and k's become, or k plus k is 2k. And then 4 minus 1 is a 3. So a positive 3 over 4. And now we have k plus 4 over 4k. So now what we're actually going to have to do is cross multiply. Okay? So cross multiplying here, 4k comes up here, and the 4 goes up there. So when we do that, we have 2k plus 3 times 4k, and that's equal to 4 times k plus 4. So now let's multiply this out. 4k, or distribute, right? 4k needs to be multiplied by the 2k, and 4 times 2 is 8, and so we have 8k squared. Then 4k times the 3 here, and that's going to be a plus a 12k. Now, what we can do here, we see, okay, we got 12k, and then we do the same thing with the 4. 4 times k, 4k, and 4 times 4 is 16. All right. So now let's bring everything over to one side. All right. So bringing everything over, we subtract a 4k and subtract a 16. So we subtract a 4k here and subtract a 16. Continue the work up here, and we're left with 8k squared. And then 12k minus 4k is another 8k plus 8k. And then we have a minus 16 left over, minus 16. And that's equal to 0. And before we start factoring, let's see if we can simplify. I see that 8 goes into all parts here, so let's go pull out an 8. 8 times k squared plus k minus 2. Okay, that equals 0. So I pulled an 8 out of all 3 parts there. Now that makes it easier to factor because right now I could technically divide both sides by 8. Those 8's cancel, and now I'm left with something much easier to factor. K squared plus k minus 2 equals 0. So we ask ourselves this question. What two numbers multiply to be negative 2, but add to be a 1? Okay. All right. So what two numbers multiply to be negative 2, but add to be positive 1? And that's going to be a k, all right, minus 1, and a k plus 2. Okay. So it's a positive 2 and minus 1. Those are two numbers that multiply to be negative 2, but add to be a positive 1. The b value that's in front of that k there. Okay, so we factor that out. And so now it's pretty simple. Set each one individually equals 0. K minus 1 equals 0. K plus 2 equals 0. And so we have a final answer of k equals 1. And k equals a negative 2. Now, one thing though we have to check is for extraneous solutions, right? So we have our two answers here. We got to check it. They told us to. So what we do is we plug each one back into our original equation and see if it holds true. So we'll start with 1. K equals 1 here. Okay? Well, every single time we see a k, we're going to put a 1 in for our equation. So we have 1 plus 4 over 4 plus 1 minus 1 over 4. And does that equal 1 plus 4 over 4 times 1? All right, 1's in for all the k's. All right, simplify. 1 plus 4 is 5, so we have 5 fourths here. Plus 1 minus 1 is 0, so we have 0 fourths. And 1 plus 4 is 5, 5/4. Well, 0 to 4 is 0, and so we have 5/4 here, equals 5/4. Since that's a true statement, we know 1 is a true solution. Now let's try with k equal to -2. K equals -2 here. Again, same process. We take our original equation and we substitute -2 in for k and see if the left and right hand side are equal. So, -2 plus 4, I hate writing low, over 4 plus -2 minus 1 over 4 equals -2 plus 4 over 4 times -2. All right, and that should be all the case. Yeah, so let's simplify. -2 plus 4, that is a +2. We have 2/4 here. Plus -2 minus 1 is a -3, so we have a -3/4. Equals -2 plus 4 is a +2. We have +2 here, over 4 times -2, a -8. So we have a -8 here. Well, 2/4 plus a -3/4, okay, that's a -1/4. Okay, and then 2 over -8 simplifies to be a -1/4. Again, left and right hand side are equal, confirming that -2 is a solution, so our final answer are both values, k equals 1 and k equals -2. 1 over 2m squared is equal to 1 over m minus 1/2. Okay, so one thing we can do is we want to add these fractions together, but they don't have the same denominator. So we want to make a like base here. So what I'm going to do is make both bases together 2m. So 1/2 gets multiplied by m over m to make 2m in that base, and 1 over m gets multiplied by 2 over 2. Okay? What that does is give us a base of 2m for both of them, allowing us to combine it. So let's bring this down. 1 over 2m squared equals, well, we have a base of just 2m, so the numerator, 1 times 2 is 2, minus m times 1 is m. All right, much simpler now. Well, we want to cross multiply, but before we do that, I do like a half cross multiply. You don't actually have to multiply both across to their corners, okay? And what I can do is I'm going to take this 2m squared and just bring it up to the right. So we have 1 left over here equals, now watch this, 2m squared times, in parentheses, 2 minus m over 2m. And what this allows me to do is kind of cancel some things out. I like to keep everything separate and cancel what I can. The 2's will cancel here, right? Boom, and cancel that out, right? Because it's just one term here. And m squared gets canceled out with this m. So now we're left with just 1 equals m times 2 minus m. All right. Let's go distribute this m across like so. Now we have 1 equals m, or 2m, sorry, 2 times m is 2m, and minus m squared. If we subtract a 1 to both sides and rearrange, we have 0 equals negative m squared plus 2m minus 1. Now looking at this, I actually like to rearrange it kind of the other way. Bring everything over to the other side. So I like to keep my m squared positive when I factor. That's a preference of mine. So essentially I'm going to bring everything over. I'm going to add an m squared, subtract a 2m, and add a 1 to both sides. I didn't recognize that earlier. So we have m squared here minus 2m plus 1 equals 0. And that's a much easier problem to factor. So let's ask ourselves a question. What two numbers multiply to be a positive 1 but add to be a negative 2? And those two numbers are minus 1 and a minus 1. So we have m minus 1 here, and m minus 1 is equal to 0. And so it's the same when we solve for m, right? We can set both of these equal to 0. M minus 1 equals 0. M minus 1 equals 0. It's the same thing. m equals positive 1 for both of them, and we only need to write that once. M equals positive 1, or in my case, 3 times, okay? So they tell us here now we want to check our answer. Let's check it. So we're going to check for extraneous solutions, so I'm going to put that 1 and plug it in for every single m of our original equation. So we have 1 over 2 times 1 squared equals 1 over 1 minus 1/2. Okay? Now, we're going to keep the left and right hand side separate and just simplify both of them and see if they're equal. So 1 squared is just 1, 1 times 2 is 2, so we have 1/2 here on the left. 1 over 1 minus 1/2, well 1 over 1 is 1, right? Minus 1/2 is 1/2. Left and right hand side are equal, meaning m equals 1 is our only true solution. N squared minus n minus 6 over n squared minus 2n plus 12 over n is equal to n minus 6 over 2n. All right. Well, one thing I want to do is I want to have the same base when I add these together. So to do that, hopefully you can see it, if I multiply the second fraction by n over n, kind of fit it in here, n over n, that will give us a denominator of n squared, meaning that we can add them together. All right, so let's simplify what we can here. And now remember, this n here will get distributed to both parts. Let's put a little parenthesis around there. Makes it a little easier to see, okay? Hopefully you can see that it's an equal sign here. All right. So left-hand side here, or left over here, let's keep the same. N squared minus n minus 6 over n squared. And the right-hand side, n times 2n is a 2n squared, plus 12 times n is 12n, all over n squared. And the right-hand side, keep the same, n minus 6 over 2n. So now let's combine the left-hand side together in the same base, and let's remember, let's see if we can get everything over. Watch this. Add, this be a negative, we're distributing that minus sign, and this is also a negative there. Okay? So now we have n squared down here, and let's combine what we can. N squared minus 2n squared, that's just a minus n squared here. Minus n plus a negative 12m, that's a minus 13n, and then minus 6 is by itself. There's no like term over there. Okay? And over here we have n minus 6 over 2n. So let's keep going. I'm going to take this denominator of n squared and bring it up here to the right. It's kind of like cross multiply, but just one of them. You'll see why in a second. So we have minus n squared here, minus 13n minus 6 equals n squared times n minus 6 over 2n. Okay? Well, what that does is this n here can cancel with this n squared. Okay? And actually, I should have multiplied this 2 up, or I can do it now, so it's easier to see. Now I'm going to take this 2 and just multiply it to this side, kind of cross-multiply now up there. It's kind of over 1 here. And I kind of separate a little bit. I just always kind of look ahead to see what I can cancel out. So let's put the 2 on the outside, or multiply that 2 across, sorry. We have a minus, or 2 times minus n squared minus 2n squared minus 2 times 13 is 26. 26n. And 2 times minus 6 is a minus 12. That's equal to, let's multiply this out, n times n is n squared, and n times a minus 6 is a minus 6n. Okay, what I'm going to do is, some kind of out of space down there, I'm going to kind of go up here, but I'm going to bring everything over to one side or the other. Now, I'm going to choose to bring everything over to the right because I prefer having positive coefficients for the n squared value. So bringing everything over, if I add it plus 2n squared here, plus 2n squared, add that together, and that's going to be equal to 0 at the end. That's a 3 n squared. Then we add a 26n to both sides. And a minus n plus 26n is just a 20n. Okay? And we add a 12 here. And we add 12. And we're left with a 12, and we have a 0 here left over. Okay? So now we want to solve for, well, we want to see what we can do to solve for n. Okay? So let's go see what we can factor here. Okay? So 0 equals, we have to have a 3n and then a regular n. Okay? And so we multiply this out. Okay, what two numbers, when we multiply them together, right, just the n's are going to equal 12, but when I add with the combination, all right, we have to have a 20 with a 3 being multiplied by one of them there. Okay, so, well, 12, I'm thinking 6 and 2, okay, 6 and a 2 here. So if I put a, let's say, a plus 6, well, plus 6 and 2, so 6 and 2 is 12, look at all the multiples for 12. If I have a 6 here, so if I do plus 6, and this is a 2, plus 2, 2 times 6 would be that 12. Yeah, and 3 times 6 is 18, and 2 plus n is 3 times 6 is 18, plus 2 is 20. That will get us there. So we can factor this to be here, and it kind of helps me a little cheat sheet here, but that's all good. So now let's solve for n. We set both parentheses equal to 0. 3n plus 2 equals 0, and n plus 6 equals 0. Keep going. We solve minus 2, and 3n equals negative 2. Divide both sides by 3, and n equals a negative 2 thirds. Subtract a 6 to both sides, and n equals a minus 6. All right. They tell us now that we have to check for our extraneous solutions here. Make sure we're all good. All right. So what's the check here? I'm using a calculator to tell. And so we're going to plug each value into our original equation and see if the left and right hand side are equal. So let's do negative 2 thirds first. Negative 2 thirds squared minus a negative 2 thirds minus 6 over negative 2 thirds squared minus 2 times negative 2 thirds plus 12 over negative 2 thirds equals a negative 2 thirds. If you can fit, we're getting close. Negative 2 thirds here minus 6 over 2 times a negative 2 thirds. Okay. So I'm going to try to simplify actually a whole bunch at once here, so bear with me with the calculator here. Okay, so we have a negative 2 thirds squared minus a negative 2 thirds minus 6. Okay, and we're going to divide that by our denominator, which is negative 2 thirds squared. And this whole side comes out to be right here. This whole thing comes out to just be, well, that's a negative 11. Minus this part here. 2 times a negative 2 thirds plus 12 divided by a negative 2 thirds. And we have a negative 16. Okay, kind of cool. It comes out pretty evenly. So far on integers, negative 2 thirds minus 6 divided by 2 times negative 2 thirds, and we should have a positive 5 here. Well, minus a negative, same thing as adding a positive, and negative 11 plus 16 is a 5. So 5 equals 5. Left and right hand side are equal, so negative 2 thirds is a solution. Let's check the 6 now. So the second one here, again, same process, put negative 6, in for n, and see if the left and right hand side are equal. Negative 6 squared minus a negative 6 minus 6 over negative 6 squared minus 2 times negative 6 plus 12 over a negative 6. Is that equal to, so many sixes, negative 6 minus 6 over 2 times a negative 6 here. All right, let's get this one first. Negative 6 squared minus a negative 6 minus 6 divided by a negative 6 squared. This becomes a good old 1. Here, 2 times a negative 6 plus 12 divided by a negative 6 is 0. Equals, right hand side, let's go. Negative 6 minus 6 divided by 2 times a negative 6. And we have positive 1. 1 minus 0 is 1. So my left and right hand side are equal, both being 1, meaning our two answers work, and n equals negative 2/3 and negative 6. 3x squared plus 24x plus 48 over x squared plus a x minus 6 over 2x squared, and that's equal to 1 over x squared. Okay. Well, one thing we want to have is a common denominator across the board here. So my first step to do that, I see there's a 2x squared here, and then x squared, and x squared. So if I multiply this one on the right here by 2 over 2, its denominator will be 2x squared. Same thing over here. Multiply this one by 2 over 2, denominator becomes 2x squared. So from there, multiply that out, right? And I'm actually going to, when I do that, the denominator, we write as really just one big denominator now, 2x squared. We have 2x squared here. Distribute this 2, though, of the numerator across. So 2 times 3x squared is 6x squared. 2 times 24 would be a 48x. And then 2 times 48 is a good old 96. Make sure we add the other 2 plus x minus 6. And that's equal to here 2 over 2x squared. Alright, now I'm going to do a few steps and kind of one here. I'm going to multiply this denominator. And it's like cross multiplication, but I'm only going to bring this side over here. And really what we can see, hopefully in the next step, is that that's going to cancel out with this denominator. So up here, let's simplify what we can. 6x squared, and then 48 plus x is a 49. X, and then 96 minus 6 is a 90. So you have 90 here. And that's equal to, just to show you, 2 times 2x squared over 2x squared. Now these will cancel, and I kind of planned that ahead of time where I wanted to go with it. So now we have 6x squared plus 49x, plus 9, plus 90 equals 2. Subtract 2 to both sides. We have 6x squared plus 49x plus 88 equals 0. Now, this does factor. You could solve many ways, factoring, graphing, quadratic formula, but this will factor to be 3x plus 8 times 2x plus 11. Alright? So now we can set each one equal to 0 and solve for x. So we do that, we have from here 3x plus 8 equals 0, and 2x plus 11 equals 0. Subtract 8 to both sides, 3x equals negative 8, and divide through both sides, x is a negative 8/3. Okay? Same thing here, subtract 11 to both sides. Well, I'll kind of show my work there, but don't need to. So 2x equals negative 11. Divide both sides by 2, and x is a negative 11 halves. So we have our two numbers there, and they tell us that we need to check that. Check for extraneous solutions. So all we're really going to do here is take my original equation, and for each one, and instead of x, we're going to put in the value and see if the left and right hand side are equal. So first part here, 3 times negative 8/3 squared plus 24, negative 8/3 plus 48 over a negative 8/3, that's me squared, plus a negative 8/3 minus 6 over 2 times a negative 8/3 squared is equal to 1 over a negative 8/3. Alright, so again, we're going to see if the left and right hand side are equal. If they are, this is a true solution. So, keep going here. Let's simplify. I'm going to do it all kind of one, actually, so I'm running out of space. So all one step here, this whole numerator. So, we have 3 times the negative 8/3 squared plus 24 times the negative 8/3 plus 48. That's like 5.3 repeating, and that's going to be divided by negative 8/3 squared. And this as a fraction is just good old 3/4. Pretty simple. Plus negative 8/3 minus 6, calculators are wonderful things, divided by 2 times a negative 8/3, again squared. And this as a fraction is negative 39 over 64. And what's 1 divided by negative 8/3? Negative 3/8. Yeah, negative 3/8. Add these two fractions, 3/4 plus a negative 39 divided by 64. And I got something slightly off. I got 9/64. So I'm actually going to double check my work here. Something might have been off. I think it's this one. So it's always going to double check when this doesn't happen first. Don't assume you always got it wrong. Alright, divided by 2 times negative 8/3 squared. Oh, I wonder if that was it. That's right. Aha, I see what I did. I didn't square that. See? So always look through. I realized, I looked back here. I forgot to square that, so that's what happened here. Okay, so let's double check that. So erase this. So we have a 1 divided by negative 8/3. That's a y. 1 divided by negative 8/3. And make sure we square the denominator. Aha, this fraction here is a 9/64. So let's go add these two together now. 3/4 plus a negative 39 divided by 64. And here we got it. As a fraction, we have 9 over 64. So the left and right hand side are equal. So one thing, note here, you see I made a mistake, right? But we just forgot the little square. Instead of going back and trying to restart everything, just kind of double check this part. You might have made a silly mistake, like I did, forgetting to square it. Okay? Well, we have two numbers, so this one we know works, so we have to check the other one. So we know x will equal a negative 8/3. Let's double check the other one. So the other check here was negative 11/2, same process. 3 times the negative 11/2 squared plus 24 times the negative 11/2 plus 48 over negative 11/2 squared. Oops, let me give myself a little room here. Plus negative 11/2 minus 6 over 2 times negative 11/2 squared. And that's going to equal 1 over negative 11/2 squared. So again, for every x value, we're putting negative 11/2. Don't forget the squared there. So let's see if the left and right hand side are equal again. This part here, let's do it once. 3 times negative 11/2 squared plus 24 times negative 11/2 plus 48. And that is 6.75. And then we're dividing that by negative 11/2 squared. And that as a fraction is 27 over 121. This next part here, negative 11/2 minus 6 divided by 2 times the negative 11/2 squared. And oops, that's an extra parenthesis, don't need that there, okay. And this as a fraction is negative 23 over 121. And one clue I see here is they're both 121 denominator. Probably is right as I typed it in, but that's a common mistake is typing it wrong. Alright, right hand side, 1 divided by negative 11 halves. Make sure we square it. And that as a fraction is 4 over 121, and we can see that, right, same denominator, subtract the numerators, 27 minus 23 or plus a negative 23 is 4, so 4 over 121 equals 4 over 121, so negative 11 halves is a solution, and so my final answers here are x equals negative 8/3 and x equals a negative 11 halves. K squared plus 2k minus 8 over 3k to the third power. And that's going to be equal to 1 over 3k squared plus 1 over k squared. Okay. Well, one thing I want to have is the same denominator across the board. We have a 3k to the third power. So if I multiply this first one here by k over k, our denominator, make sure this is multiplication right, become 3k to the third power. The second part here, the last part here, if I multiply this by 3k over 3k, make sure, the reason why we multiply the same thing over itself, because that's essentially 1, doesn't change the problem. 3k times k squared is a 3k to the third power. So when we multiply this out, we should have the same denominator. So the left-hand side here, I'm going to leave as it is for the moment. We have k squared plus 2k minus 8 over 3k to the third. The right-hand side, we know we're having, the goal was 3k to the third power in the denominator. So we can put it together as 1. K times 1 is k, plus 3k times 1 is 3k. Alright, now watch this little trick I like to do. I'm going to take this whole denominator here, and it's kind of like cross multiplying, but I'm only multiplying this one up and across. Okay? So I'm going to multiply both sides by 3k to the third. But what that does, right, and essentially, right, I multiply both sides by 3k to the third here, and this side by 3k to the third, cancels that out. And so now, and these cancel, right? And that leaves me with just k squared plus 2k minus 8 equals k plus 3k. Okay? So let's bring all of our like terms together. Let's bring everything to the left. Subtract a k to both sides, so we have k squared plus 2k minus this k, right? Subtract the k. And we're left with just a 1k. Oh, but then we also subtract a 3k from there. I almost got ahead of myself. That's what I get for skipping steps here. That's fine. Good job, Sean. Kind of got ahead of myself. That was just a 3. Alright? So 3k plus k is 4k. So if we subtract a 4k to both sides, let's keep that there, 4k, we have k squared minus 2k minus 8 equals 0. Alright? Well, as factors, what two numbers multiply to be negative 8, but add to be negative 2, and that's minus 4 and positive 2. So we have k minus 4 and k plus 2, and that's equal to 0. So solving that, pretty easy. We set each one equal to 0. K minus 4 equals 0. K plus 2 equals 0. And so my two options for k here are k equals a positive 4, remember, add 4 to both sides, and a minus 2, okay? Or minus 2 positive 4, however the order you want to have. But we told us that we have to check here, okay? So we've got to make sure we check both of these. So to check here, what I'm going to do is I'm going to take each number individually, plug it to my original equation, and see if the left and right hand side are equal. So let's do 4 first. 4 squared plus 2 times 4 minus 8 over 3 times 4 to the third power. And that should equal 1 over, remember the original equation, 3 times 8 squared, plus 1 over 8 squared. Okay? Let's see if we can get this whole big fraction at once here. 4 squared plus 2 times 4 minus 8. That's all going to be 16. And we're dividing that by 3 times 4 to the third power. And our fraction here should be a 1/12. Next one, 1 divided by 3 times 8 squared. And that as a fraction is 1 over 192 plus here 1 over 64, right? 8 squared, 64. We add that together to 1 over 192. And I have 1 over 96. So left and right hand side aren't equal. All right, let me just double check that I did everything right before I make that claim. Got 4s here. Oh, that's what I did. I jumped these to be an 8. Silly me. 4, quick fix. I don't know why I thought that was an 8. Anyway, quick fix. I'm sure you guys are watching like, what the heck? How did you get that? I don't know. If you think you know where I got the 8 from, not sure why I grabbed that 8. I mean, I was looking at that. We have 4 squared and 4. Easy fix here. 1 divided by 3 times 4 squared. 1 divided by 3 times 4 squared. And that is a fraction, is 1 over 48. And well, that's 1 over 16. So we add, right, 4 squared 16. So we add 1 divided by 48 to that, and that fraction is a 1/24. Did I do this right? Divided by 3, can I save this problem? 4 squared. I don't know, it's right. I don't know what I typed here. 1/48 plus 1/16 is a 1/12. Okay, so after a few checks here, these two left and right hand sides are equal. Okay, I knew the answer 4 is a true answer. Just double check it here. So let's do it again. All right, now again, be careful with typing things in. It's so easy to make a mistake, as you can see. Same thing with -2 here. Hopefully I don't make a mistake here. -2 squared plus 2 times -2 minus 8 over 3 times -2 to the third power equals 1 over 3 times -2 squared plus 1 over -2 squared. All right. All typed in right? All right, let's go left fraction. Let's see if we can get this done pretty quickly. -2 squared plus 2 times -2 minus 8, and we're dividing that by 3 times -2 to the third power. And that fraction here is just good old 1/3. Here, 1 divided by 3 divided by -2 squared. And our fraction for that is just 1/12 again. And plus here, 1 divided by -2 squared. And so 1/4, I should have known that. We add that to 1/12. And please say we get 1/3. We do. Left and right hand side are equal. Good. And so -2 is also an answer. And one thing you should see, it's always good to always double check. Even your check, you might have made a mistake there. Either way, our final answer are 4 and -2. K over 3 minus 1 over 3k is equal to 1 over k. Now this one, I want to have all the denominators to be 3k. So to do that, this first part should be multiplied by k over k, and the last part here be multiplied over 3 over 3. So let's kind of bring this together. This denominator here, when we subtract them, shares k times 3, or 3k. So our numerator, we have k times k is k squared, and then it's just minus the 1. Here we have 3 over 3k. Now I'm going to multiply both sides by just this denominator, 3k, to cancel out the division, and look, it cancels out both sides. So now we're left with k squared minus 1 equals 3. Well, this one's actually pretty easy. We add 1 to both sides, and we're left with k squared equals 4. Square root both sides. Remember, that's the opposite of squaring, square root. And we have k equals plus or minus square root of 4, which is 2. Don't forget your plus and minus. So let's go check that, because they told us we need to check for extraneous solutions. So take our original equation and plug 2 or negative 2 in. Let's go 2 first. 2 over 3 minus 1 over 3 times 2 equals 1 over 2. All right? Now we're going to see if the left and right hand side are equal. Well, we have 2/3 here. Oh, kind of a little thing. Get ahead of myself. 2/3, not 3/2. 2/3 minus 1/6 equals 1/2. Okay? Double check in here. 2/3 minus 1/6 should be a 1/2. And it is. So since the left and right hand side are equal, a positive 2 is a solution. All right, let's try a negative 2. Same idea. Negative 2 over 3 minus 1 over 3 times a negative 2. And that's equal to 1 over a negative 2. Let's see if that's true. Negative 2/3 here minus 1 over negative 6 equals a negative 1/2 minus a negative 6, adding a positive. So negative 2/3 plus 1/6 should be a negative 1/2. But let's just double check here, because I have the calculator, so why not? And we do have a negative 1/2. So for both of these, the left and right hand side were equal when we plugged in 2 and negative 2 in. So our values for k, you can write like that, or as a negative 2 and a positive 2. And there is our final answer. X minus 4 over 6x plus x squared minus 3x minus 10 over 6x. And say that's equal to x minus 1 over 6. Well, I notice all of these have the same denominator except for the right. We just have a 6 here. So to fix that, we multiply that part by x over x. We should get a 6x in the denominator. Okay. Left-hand side, same denominator. Let's add them together. Combine, we get a 6x in the denominator. Okay. In our numerator, we'll add our like terms. No x squared there. Negative 3x and a positive 1x is a minus 2x. Negative 4 and negative 10 and a negative 14. Here we have x minus 1. And actually we're distributing it, so x times x is x squared, and x times 1 is an x. X squared minus x. All over 6 times x, 6x. Now, if I take this denominator right here, and I multiply that to both sides, which I'm allowed to because it's being divided by, these will cancel, and so will this. Makes it a much easier problem to solve. X squared now minus 2x minus 14 equals x squared minus x. Bring all of our like terms together to the left, subtract an x squared to both sides, and hopefully you can see they cancel, right? That actually makes it easier. We add an x to both sides, and we have, well, negative 2x plus x is a negative x minus 14 is equal to 0, which is left over on the right. Get x by itself, we add a 14, both sides. Negative x equals 14, and so x equals a negative 14, right? Multiply both sides by negative 1. So They tell us, though, that we need to check this, right? Check that answer, okay? So to do that, we take our original equation and we plug in negative 14 in for x and see if the left and right-hand side are equal to. Negative 14 minus 4 over 6 times the minus 4 plus negative 14 squared minus 3 times the negative, see again, negative 14, don't forget that, 14, minus 14 minus 10. If you caught that, let me know in the comment section. 6 times negative 14 equals negative 14 minus 1, why do I say 14 weird, over 6. So let's simplify. Let's get this part here. Negative 14 minus 4 divided by 6 times the negative 14. And this as a fraction is 3 over 14. Plus here, negative 14 squared minus 3 times negative 14 minus 10 divided by 6 times negative 14, and that as a fraction is negative 19 over 7. All the way to the right, negative 14 minus 1 divided by 6, and as a fraction, it's just negative 5 halves. All right, so let's see if this equals negative 5 halves. 3 divided by 14 plus a negative 19 divided by 7, and we get a negative 5 halves here. So the left and right hand side are equal, making our final answer here, the negative 14, true. So here we have a final answer, x equals a negative 14. 1 over x squared is equal to x minus 1 over x plus 1 over x. All right. Well, first thing I want to do here is I want to have a common denominator across the board. So to do that, I'm going to multiply this part here by x over x and this part by x over x as well. That gives us an all denominator of x squared. So 1 over x squared here is equal to, now let's make sure we distribute. We have an x squared in the denominator, right? X times x is x squared. X times x squared here, x times 1, 1. So we x minus an x, and x times 1 is just an x. So now we have x squared minus x plus x. All right. So this is actually pretty good here. So watch this. I'm gonna let's just do this. Let's go multiply both sides by x squared here. This will eliminate that, giving us a 1. These cancel out as well. Now we can combine the numerator. Negative x plus x is just, well, 0, right? They cancel each other out. So we're left with just x squared here. So now we have 1 equals x squared. Remember, to get rid of that, we square root both sides. Well, square root of 1 is just 1, but since we took the square root over the equal sign, plus or minus, so we have plus or minus 1 equals x. So x comes first, x is plus or minus 1. So this one's actually pretty easy. We just need to check now for our extraneous solutions. So we're going to take our original equation and put 1 in for x and negative 1 in for x as well. Let's go 1 first. 1 over 1 squared. Now be careful, I probably will make a mistake with my 1's, but I always make those little mistakes. Put 1 in for every x of the original equation. 1 squared is 1, 1 over 1 is 1, right? 1 over 1, everyone write it. 1 minus 1 is 0, so it's 0 over 1 plus 1 over 1. The left and right hand side will be equal, 0 over 1 is 0, and we have 1 equal 1. Great. Now let's check a negative 1. 1 over negative 1 squared equals negative 1 minus 1 over negative 1. Plus 1 over negative 1. Negative 1 squared is a positive 1, so we have 1 over 1 here. Negative 1 minus a 1 is a negative 2, minus 2 over negative 1. plus 1 divided by negative 1 is a negative 1. Negatives cancel out here. So now I have 2 plus a negative 1 is a positive 1. So 1 equals 1. Left and right hand side are equal, meaning my final answer here is just x. Both of them are true solutions. X equals plus or minus 1. 1 over r plus 3 is equal to r plus 4 over r minus 2 plus 6 over r minus 2. Okay? Now one thing I want to do here, I first am going to look. I see the right-hand side has the same denominator already, so I want to combine that together to one fraction. So we have 1 over r plus 3 equals, well, we add the numerator, right? R plus 4 plus 6 is just r plus 10, right? We have r plus 10 here, and the denominator r minus 2. Now I'm going to cross multiply. I'm going to cross multiply here, get everything to the numerator. 1 times r minus 2 is just r minus 2. Right hand side, we have, well, r plus 3 times an r plus 10. Okay? We want to FOIL that out, the right hand side. So left is r minus 2. R times r is r squared. R times 10 is 10r. 3 times r is 3r. Add them together, we have 13r. And 3 times 10 is 30. Okay? So let's bring the r and the plus or minus 2 to the right-hand side. So we have 0 equals r squared is there, but subtract r, and 13r, we have a 12r. Add 2 to 30, and we get 32. Well, now we need to factor this, and this factors to be r plus 8 times r plus 4. What two numbers multiply to be 32, but add to be 12? That's 8 and 4. Keep going to simplify. All right, set both of those now equal to 0. R plus 8 equals 0. R plus 4 equals 0. Equals 0. That's an equals. And so r equals negative 8, and r equals a negative 4. Now they tell us we need to check for extraneous solutions. So to do that, what we want to do is take our original equation and plug in each corresponding value for the variable and see if the left and right hand side are equal. So let's do negative 8 first. Negative 8 plus 3 equals a negative 8 plus 4 over negative 8 minus 2 plus 6 over negative 8 minus 2. All right, I like to just kind of do it all on my calculator here so I don't make a mistake, but that's not always foolproof. So 1 divided by negative 8 plus 3, and that is just a, is that right? Oh, it is right. Oh my goodness, negative 1/5. Whoopsie there. All right, negative 8 plus 4 divided by negative 8 minus 2. And this fraction here is a, no, I didn't write that, but good. It's good. I caught it. Negative 8 plus 4 divided by negative 8 minus 2. That's what I did. I put a 9 instead of a parenthesis. And that fraction is just a 2/5. Looking good so far. 6 divided by, I should put division in there, divided by negative 8 minus 2. And that fraction is a negative 3/5. Well, 2/5 plus a negative 3/5 is a negative 1/5. Left and right hand side are equal, and so we know that negative 8 is a solution. But there's two numbers, we got to check the other one. Same idea, put negative 4 in for r. 1 over negative 4 plus 3 equals negative 4 plus 4 over negative, I almost put 8 in, be careful, negative 4, that's a negative 4 minus 2 plus 6 over negative 4 minus 2. Okay? Well, first things, 1 over negative 4 plus 3 is a negative 1, so we have a negative 1 over 1 here. Equals minus 4 plus 4 is 0. It doesn't really matter where the denominator is, right? It's going to be 0, but minus 4 minus 2 is a minus 6. Okay? Keep going. Minus 4 minus 2 is a minus 6, so it's 6 over minus 6. Well, this is 0, cancel it out. 6 over negative 6 is a negative 1, and negative 1 over 1 is negative 1. Left and right hand side are equal, so our two values for r are negative 4 and negative 8. They both are true. A squared minus 4a minus 12 over a squared minus 10a plus 25 is equal to 6 over a minus 5 plus a minus 3 over a minus 5. This one's a little tricky. There's a few ways to kind of go about it, up to you and how you want to see it. Part of me kind of looks ahead and sees that we have, well, a minus 5 here, and maybe if I somehow can get this right there. Okay, well, I know a minus 5 times a minus 5 will equal that a squared minus 10a plus 25. Okay, and I know that because, well, kind of look ahead. If I multiply it by itself, kind of looking at it, a times a is a squared. A times minus 5 is minus 5. Minus 5 times a is minus 5a, right? Minus 10a. Negative 5 is 25. And we can do that. But that means that this also will kind of factor out as well. So, many ways to solve it. I'm just going to make it all the same denominator. Eventually we'll cancel. But if I do this, multiply by a minus 5 over a minus 5 times a minus 5 over a minus 5. What we have is, keep this thing the same, on the left, a squared minus 4a minus 12 over a squared minus 10a plus 25. Here, I know that denominator is going to be the same when I multiply that out, so this whole thing is going to have that same denominator, a squared minus 10a plus 25. When you kind of FOIL that, right, make sure you do something like this. It's a little easier to see. Okay. The numerators, right, 6 times a is 6a, and 6 times minus 5 is minus 30. Same thing here, we can multiply that out. A times a is a squared. A times minus 5 is minus 5a. Minus 3 times a is minus 3a. Together is minus 8a. And then negative 3 times the negative 5 is a positive 15. Okay? Well, watch this. I'm going to multiply both sides by this denominator right here. Okay? In doing so, if I can fit it on the other side, I don't think it's going to fit, but if it goes off the screen, you know that's what I'm doing. Multiplying both sides by this denominator. It's going to cancel because they're the same, and now I'm left with just a squared minus 4a minus 12 is equal to, let's combine our like terms, only one a squared here, okay? 6a and negative 8a is a minus 2a, and minus 30 plus 15 is a minus 15, okay? Now let's get all of our like terms together. Well, look, the a squared is going to cancel right there. They cancel on both sides. Let's bring the 2a over. So add a 2a to both sides. We have a negative 2a over here. Let's add a 12. Let's bring the 12 to the right, actually. We have a negative 3 here, right? Negative 15 plus 12 is negative 3. Divide both sides by negative 2. And a equals a positive 3/2. So they tell us that we need to check our work. Okay? So to check that, we take our answer and plug it into the original equation. So let's do that. 3/2 squared, and this is where I like having a calculator, minus 4 times 3/2 minus 12 over 3/2 squared minus 10 times 3/2 plus 25 equals, make sure this goes to the original so don't ignore the a minus 5 over a minus 5s, 6 over 3/2 minus 5 plus 3/2 minus 3 over 3/2 minus 5. Kind of double checking here, it's all the same. I think so. If we don't get the right answer, we can always come back and check that. Looks good to me. Alright, so let's go simplify what we can up here. 3/2 squared minus 4 times 3/2 minus 12. Okay. Divided by, do it all at once, 3/2 squared minus 10 times 3/2 plus 25. And this becomes a good old fraction of -9/7. 6 divided by 3/2 minus 5. And this is a fraction is -12/7. This one here, 3/2 minus 3 divided by 3/2 minus 5. And that as a fraction is 3/7. Well, -12/7 plus 3/7 is -9/7. So the left and right hand side are equal, meaning that A equals a positive 3/2 is a real solution. And our final answer. 1 over n plus 3 plus n squared plus 6n plus 5 over n plus 3 is equal to n minus 3. Alright. The left side here, we had the same denominator, so we can combine that to one big fraction. So we have n plus 3 in the denominator, and really we just add the numerator. The only thing that adds is 1 and the 5 is the 6. Only like terms. So we have n squared plus 6n plus 5 plus 1 is 6. N minus 3 here. Okay? Now, if I multiply both sides by this denominator, okay, that denominator cancels, leaving me n squared plus 6n plus 6 here. And then this multiplies, well, n times n is n squared, right? And then n times 3 is 3n, and minus 3 times n is a minus 3n. They cancel, don't really worry about that. Minus 3 times 3 is a minus 9. Well, I see an n squared on both sides, the equal sign here, positive. Cancel that out. So now we're left with 6n plus 6 equals -9. Pretty simple. Minus 6 to both sides. Okay. Then because of 6n equals a -15 divided by 6 to both sides. -15 divided by 6 simplifies to be n equals a -5/2. So now they tell us that we should check for an extraneous solution. So we got to check here, and to do that, we're going to plug -5/2 in for n and see if the left and right hand side are equal into our original equation. So let's do that. 1 over -5/2 plus 3 plus -5/2 squared plus 6 times -5/2 plus 5 over -5/2 plus 3 is equal to -5/2 minus 3. Okay. Let's deal with this one. 1 divided by -5/2 plus 3, and that as a oh, that's just 2 straight off the bat. That's a 2. Let's deal with this one here. -5/2 squared plus 6 times -5/2 plus 5 divided by -5/2 plus 3. And this, as a fraction, is -15/2 equals here -5/2 minus 3, -11/2. So 2 plus a -15/2 is, 2 plus a -15/2 is a -11/2. So our left and right hand side are equal, meaning that our answer of -5/2 is a true solution, and so there is our final answer. 1/2 is equal to x squared minus 7x plus 10 over 4x, and that's minus 1 over 2x. Well, I want to have the same denominator across the board here, and that's 4x looks the most complex. Well, the 2x can become a 4x if I multiply this by 2 over 2, right? 2 times 2x, that's 4x. 1/2, or 2, can be a 4x if I multiply this by a 2x over 2x. 2x times 2 is a 4x. So let's deal with the right-hand side first. We have 4x down the denominator, what we wanted. So let's rewrite this x squared minus 7x. And then 2 times 1 is a 2, and a 10 minus a 2 is an 8. So we have an 8 right there. Now we have this as just 2x over 4x. Now watch this. If I multiply 4x to both sides, these denominators cancel. I'm left with 2x equals x squared minus 7x plus 8. Alright, so now let's get everything to one side, subtract both sides really by a 2x here. And we're left with 0 equals x squared minus 9x plus 8. That's an x here. Let's factor. Well, 0 is multiplied to be positive 8, but add to be a negative 9 is minus 1 and minus 8. So x minus 1 and x minus an 8 here. Set each one individually equal to 0. X minus 1 equals 0. X minus 8 equals 0. And so x equals a positive 1 and a negative 8 there, respectively. So let's go check to see if we have an extraneous solution like they asked us to. Check. Alright. To do that, we take one of our values, plug it in for x, and see if the left and right hand side are equal. So is 1/2 equal to, let's go with 1 first, 1 squared, minus 7 times 1, plus 10, over 4 times 1, minus 1 over 2 times 1 here. Okay, well, 1/2 can stay where it is. 1 squared, which is 1, minus 7 times 1 is 7, plus 10, divided by 4. Oh, look, that's just 1. We got a 1 right here. Minus 1/2, pretty straightforward. 1 minus 1/2 is 1/2. Left and right hand side are equal, so 1's a true solution. Let's check the other one here. Okay, so the next check, let's put negative 8 in. So 1/2 equals a negative 8 squared minus 7 times a negative 8 plus 10 over 4 times a negative 8, a little more complicated this time, minus 1 over 2 times a negative 8. Well, again, here it's just 1/2. This fraction here, a little more complicated, negative 8 squared minus 7 times negative, what's division? Negative 8 plus 10 divided by 4 times negative 8. And that as a fraction is negative 65 over 16. I might have to check that answer, but we'll see. And 1 divided by 2 times a negative 8 is negative 1 over 16, or maybe not. Alright, remember, negative and a negative. Subtracting a negative is adding a positive. So what's negative 65? That's 65, not 35. Divided by 16 plus 1 divided by 16. Oh, I know this won't work. Something happened here. 4. What did I do? Let's go check this. Most likely I did something here, so it's always good to check that out. Negative 8 squared minus 7 times a negative 8 plus 10 divided by 4 times negative 8. And that fraction, negative 8, negative 8, negative 8. Kind of check in here. Positive 8. The positive 8, that's why. Positive 8, positive 8, positive 8, positive 8. So let's just go double check this. Oh, that's embarrassing. Square minus 7 times positive 8. But hey, good learning lesson here. I checked my work, something didn't seem right. I looked back and I saw I put a negative 8 instead of a positive 8. Some of you probably caught that ahead of time. So this is a 9/16 here. This is gone. This is wrong. Okay? So you have a positive 9/16. Positive, yeah. Minus, well, that's 1/16, right? Makes sense. So you have a positive here, that's a 1/16, 2 times 8, 16. 9/16 minus 1/16 is an 8/16, right? Which is a 1/2. So 1/2 equals 8/16. 1/2 equals 1/2. Bear with me here. Left and right hand side are equal, meaning both of these are true solutions. But hey, always a good learning experience, right? Positive 1 and positive 8. Those are two true solutions. 1 over k is equal to 5 plus 1 over k squared plus k. Well, first thing I know is I purposely kind of wrote this out to set myself up here, but I want to get the same denominator. There's a 5 there. So to get the same denominator, I'm going to multiply this over the k squared plus k squared plus k over itself. Okay, I'm going to put that in a little big parenthesis, right? And this is really 5 over 1, right? Right there, over 1. So what that does, it allows me to combine this as one big fraction here. So we have 1 over k on the left here, and I multiply that out. 5 times k squared is 5k squared plus 5k. And then we have a plus 1 there all over our denominator, which is k squared plus k, right? But I'm actually going to pull out a k. So we have k times k plus 1. Same thing. We will see why in a minute why I'm doing that. Okay? Now I want to multiply both sides by this denominator right there. So multiply that by k times k plus 1 and k plus 1 times k, if you can see that in there. These cancel. These k's will cancel. And now I'm left with k plus 1 times 1, which is a k plus 1, equals 5k squared plus 5k plus 1. Okay. Now, we want to get all of our values to the right. Subtract a k to both sides. And subtract a 1 to both sides. These cancel, give us 0, 5k squared. And then 5k minus 1k is a 4k, like the TVs. And 1 minus 1 is 0. So this actually becomes a little tricky. We can pull out a k here, and 0 equals k times 5k plus 4. So both equal 0. Well, k equals 0, and 5k plus 4 equals 0. Subtract 4 to both sides. 5k equals negative 4, and k is a negative 4/5. So let's write them both up here. So we got k equals a negative 4/5 and a 0. So we want to check to see if any of these are extraneous solutions, and where can we go with that? So let's do our check here. Okay. Well, first thing for our check, let's go with negative 4/5. Let's put that in for our k values in our original equation. So 1 over a negative 4/5 equals 5 plus, remember the original equation, 1 over negative 4/5 squared plus a negative 4/5. Okay? So, left-hand side, 1 divided by a negative 4/5 is a negative 5/4. Calculator confirms, negative 5/4. Here, 5 plus, what this is, 1 divided by negative 4/5 squared plus a negative 4/5. This as a fraction is negative 25 over 4. We add 5 to that, and we get negative 5/4 equals negative 5/4. Left and right hand side are equal. Negative 4/5 is a true solution. Great. Same thing with 0. Let's try it. 1 over 0. This should be a red flag, but let's finish it. 5 plus 1 over 0 squared plus 0. Well, red flag cannot divide by 0. Doesn't exist. Can't really do that, right? And left and right hand side aren't going to be equal there, so I'm fine. 0 is not a solution, so our only true solution is just -4/5. K equals a -4/5. 1 over p squared minus 4p plus 1 is equal to p minus 6 over p. Well, first thing I'm looking at here, I want to combine these two. So to do that, I need to have a common denominator. So what I'm going to do is this 1 is really 1 over 1. And we're going to multiply it, and I'm going to multiply by this denominator over itself. P squared minus 4p. I'm going to fit in there. P squared minus 4p. And what this does, it allows me to combine the two to one big one fraction here. Okay, so let's look at the numerator. Well, p squared minus 4p times 1 is p squared minus 4p. Okay, all right, so we have p squared minus 4p, and then we can't forget that there's a 1 up there actually. That's right here, put that there. Now the denominator is p squared minus 4p. I'm going to pull out a p there. So we have p minus 4, or p times p minus 4. Same thing, but it'll help us in a minute. Equal sign, p minus 6 over p. Now this is when I'm going to take this here and multiply it to both sides. So now we have p times p minus 4, and that's why I kind of saw ahead and broke that up. You didn't have to do it right away, but it helps there. These cancel. I have p squared minus 4p plus 1 equals, these p's cancel. Now with p minus 6 times p minus 4. P times p is p squared. P times minus 4 is minus 4p. Minus 6 times p is minus 6p. Together they make a minus 10p. And negative 6 times negative 4 is a positive 24. Okay. So now, well, we have p squared on both sides. They end up canceling. Okay. Let's bring our 10p to the left here. That's what I did first. Yeah. Add 10p to both sides. And I'm actually going to bring my 1 over to the right. Minus 1, minus 1. We now have a positive 6p equals a 23 divided both sides by 6. And p equals 23 over 6. Okay? So now they tell us that we need to check that for extraneous solution. So let's go check this. Check for extraneous solution. So we're going to plug 23 over 6 in for all of our p values. 1 over, almost wrote p there, 23 over 6 squared minus 4 times 23 over 6. Remember, it's the original equation, so we just have a 1 here, plus 1, is equal to 23 over 6 minus 6 over 23 over 6. Okay? So now, what I'm going to do, this fraction here, I have 1 divided by, I always love the big ones, 23 over 6 squared minus 4 times 23 divided by 6. And that as a fraction is negative 36 over 23. And we have plus 1 equals this one here, 23 divided by 6. Now there's always a chance you make a mistake running your calculator, so if it doesn't line up, always check it again. Alright, divided by 23 over 6. And we have negative 13 over 23. So what's negative 36 divided by 23 plus 1? And that as a fraction is negative 13 over 23. So the left and the right hand side are equal, meaning that p equals 23 over 6 is a true solution in our final answer. 5 over n minus 6 over n to the third power minus 2n squared equals n squared plus 5n minus 6 over n to the third power minus 2n squared. Okay. Well, what I want to do is kind of get all of them have the same denominator. The only thing that's not n to the third minus 2n squared is just n right there. So if I multiply this by n squared minus 2n over itself, we can see multiplying that out, we should get n to the third minus 2n squared. So that will give us the same denominator. So let's go do that. And so this becomes denominator, like I wanted, n to the third minus 2n squared. And the numerator, well, 5 times n squared is 5n squared. 5 times minus 2n is minus 10n. And here we just have a minus 6. Right-hand side. Okay, right-hand side is just what we have here. N squared plus 5n minus 6 over n to the third minus 2n squared. Now, I'm going to take this denominator and multiply it by both sides. N to the third minus 2n squared. N to the third minus 2n squared. These eliminate, that's the whole point. And we have 5n squared minus 10n minus 6 equals n squared plus 5n minus 6 there. Okay? So now, let's bring everything we can over to the left. Subtract to n squared. 5n squared minus n squared is a 4n squared. Subtract to 5n to both sides. And minus 10n minus 5n is a minus 15n. And we add a 6 to both sides. And that gives us, well, a 0. So we don't really need that. Negative 6 plus 6 is 0. So now this is all equal to 0. If I pull out an n, I have n here times 4n minus 15 equals 0. So set both parts equal to 0 for the multiplication. So n equals 0. And then here, 4n minus 15 equals 0. 4n equals a positive 15. And n equals a 15 over 4. So now we have to check both of these to see if there's any extraneous solutions. Alright, let's check the 15 over 4 first. Okay, so let's go do that one first. To do that, I take my original equation and I'll plug 15 over 4 in for n and see if the left and right hand side are equal. 5 over 15 over 4 minus 6 over 15 over 4 to the third power minus 2 times 15 over 4 squared. And is that equal to, so much work here, 15 over 4 squared plus 5 times 15 over 4 minus 6 over 15 over 4 to the third power minus 2 times 15 over 4 squared. Okay? All right, make sure I have it all looking good. All right, so let's see what it is. What's 5 divided by 15 divided by 4? And that is a fraction. And it's just 4/3. Minus, this one's a little more complicated, 6 divided by 15 divided by 4 to the third power. Minus 2 times 15 divided by 4 squared. And we have a 128 over 525. That might be a little red flag. I'm just kind of double checking my work. Looks like I did it right. We'll see. Here, same thing. 15 divided by 4 squared plus 5 times 15 divided by 4 minus 6 divided by 15 divided by 4 to the third power minus 2 times 15 divided by 4 squared. And what's this fraction here? Oh, 572 over 525. So let's see what happens here. What's 4/3 minus 128 divided by 525 as a fraction? I have a hunch it's the same, and it is kind of crazy, but it's true. 572 over 525 is equal to 572 over 525. Left and right hand side are equal, so 15 over 4 is a true solution. What about 0? Let's plug 0 in for n and check. So 5 over 0 minus 6 over 0 to the third power minus 2 times 0 squared is equal to 0 squared plus 5 times 0 minus 6 over 0 to the third power minus 2 times 0 squared. Well, this is dead in the water right in the beginning. We can't divide by 0, it's undefined, so we know, at least right there and here, it won't work either. 0, 0, and this one up. It's just basically we're dividing by 0 everywhere. So 0 cannot work. So nope for the 0. So our only true solution, the one we checked, right, 0 is what we call extraneous, as n equals 15 over 4. X plus 2 over x is equal to x minus 1 over x minus, I'm giving a little space there, 4x plus 2 over x squared minus 3x. Got it all. Alright. So, what I want to do first is, well, I can only combine these two fractions if they have the same denominator. We have an x here and an x squared minus 3x. So if I multiply this one here by a x minus 3 over itself, we can see x times x is x squared, x times minus 3 is minus 3x. We would then have the same denominator. So let's go simplify a little bit. X squared plus 2 over x equals, and this one down here, I'm actually going to leave it as in its separated form. X times x minus 3. And you'll see in a minute why. The numerator, though, we can multiply this out. X times x, right, is x squared. X times minus 3 is minus 3x. Minus 1 times x is minus 1x. Together, they make a minus 4x. And minus 1 times minus 3 is a positive 4. Okay? Oh my goodness, no, I was ruining the whole thing. Positive 3. Oof, it's late actually that I'm recording right now, so bear with me here. Okay. Can't really tell, but it's pretty late. I'm tired. Minus 1, minus 3 is a positive 4. Alright. Still bring all this over. Minus 4x plus 2. Now, minus 4x minus 2. Again, it is time. I'm tired. Okay, what do I do to sacrifice for you all here? I got a nice video here. You know, if you like this video, please subscribe and like the video, you know. If you like the effort, help us make more here. Alright, back to the problem. So, multiplying both sides by this denominator, x times x minus 3, and x times x minus 3 here. These will cancel. The x's cancel, okay? And now I'm left with, well, an x minus 3 times an x plus 2. And here we can combine this stuff here. Nothing with an x squared, but minus 4x and minus 4x is minus 8x. And plus 4 minus a 2. Oh, sorry. I erased it, didn't I? You can tell I'm tired here. I erased it and put it back there. The same exact thing. It's a positive 3. I'm sorry, right there. Positive 3. Positive 3 minus 2 is a positive 1. Okay, good thing I just solved the problem. Okay, so keep going. Let's FOIL that out. X times x is x squared. X times 2 is 2x. Minus 3 times x is minus 3x. So we have minus 1x here. And minus 3 times 2 is a minus 6. And bring down the rest. There's an x squared on both sides, so they kind of cancel each other out. I can add an 8x to here. And actually, I'm going to add a 6 to both sides now. So now we have 7x equals 1 plus 6 is 7. That's easy, right? Divide both sides by 7. So I'm going to write over here, x is just equal to 1. But they tell us that we have to check. Check for extraneous solutions. Don't forget that check. Don't just jump ahead and let your this tell you it's easier to do it in your head. I always hated it. Students said that. So now you didn't. Go show me the work. Put 1 in for every single x and see if the left and right hand side are equal. Okay. 1 plus 2 over 1. And we have 1 minus 1 over 1 minus, now remember it's the original equation, 4 times 1 plus 2 over 1 times 2 minus 3 times 1. All right. So now, simplify. 1 plus 2 is 3. 3 over 1 here. 1 minus 1 is 0 over 1. That's easy. 4 times 1 is 4. Plus 2 is a 6 over 1. Squared is 1 minus 3. Okay, we have a minus 3 here. All right. 3 over 1 is 3. Equals 0 over 1 is 0. Don't really worry about it. We have minus 6 over 1 minus 3 is minus 2. Negatives cancel. Positive. 6 over 2 is a 3. 3 does equal 3. That's a true statement. Meaning that x equals 1 is not extraneous, but a real solution and our final answer.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.